Hello and welcome. Today we're going to explore the exciting world of physics and chemistry by building a balloon-powered car. This project is a fantastic way to see some fundamental scientific principles in action, specifically Newton's third law of motion. The car we are building operates on the principle of Newton's third law, which states that for every action there is an equal and opposite reaction. When you inflate a balloon, you're storing potential energy from the compressed air inside. When we release the balloon's opening, this high-pressure air escapes rapidly in one direction, which is our action. The car is then propelled forward in the opposite direction, which is the reaction due to the force of the air escaping. This is the same basic principle that allows rockets and jet engines to fly. The key here is creating thrust. As the air molecule rushes out of the balloon, they create a stream of gas moving in one direction. This escaping gas produces a reactive force on the balloon, which in turn pushes the car in the opposite direction. To build our car, we'll need a few simple materials. The main frame of our car is a simple piece of lightweight cardboard. A lighter and more rigid body will help the car go farther. And for our engine, we will be using a balloon which stores the energy we need to move the car. Next is our straws. We'll use this in two ways. One straw will be our air nozzle, and two smaller pieces will act as an axle holder. Next would be our wooden skewers. These are thin, straight rods that connects our wheels. And for our wheels, we will be using bottle caps with a hole in the center. Lastly, we will be needing tape and glue, which is essential to securely attach all the parts, especially to create an airtight seal where the balloon meets the straw. First, we'll create the car's chassis from cardboard. Then, we'll cut two pieces of a straw and use hot glue to attach them to the underside of the cardboard base to hold our axles. For the wheels, we'll melt a hole in the center of 4 plastic bottle caps and insert a skewer through 2 bottle caps and secure them with hot glue to form the back axle. Slide the axle through one of the straw pieces, then repeat the process for the front axle. Finally, make sure to test that the wheel spins freely before moving on. Next, we'll attach 2 cardboard pieces to the side of our car base and add the third piece for the roof. Now, for the engine, we'll drill a hole in a bottle cap and attach a straw to create our nozzle. This nozzle then gets attached to the back of the car's roof with hot glue. For the final step, we'll attach the balloon to the straw nozzle at the back of the car. When the balloon is inflated and released, the car will move forward, propelled by the escaping air. Based on our calculations, the balloon car is predicted to start with a speed of about 14.3 meters per second and travel around 34 meters before stopping. However, in practice, the actual distances and speed will depend on the build quality, the surface it's on, and the actual balloon inflation. This project is a great demonstration of how simple materials can be used to showcase complex scientific principles.